Hey everyone, this is KMS meeting 11 for SIGAUT on March 22nd. Let's see, I think the latest things I've seen is, Christoph, you were starting to share access to your repo and stuff, and I think you guys have been organizing around that some.
Yeah, I didn't do much except giving access to the people who were in the last SIGAUT meetings, KMS meetings. So I need to add Damien too, and I need to add a couple of stories. But again, I hope that we will discuss maybe now in the meeting how we move forward. And yeah, if we take actually this repository or another repository, and yeah, then I can maybe alone or with Anish sit down and write the stories, the issues, what is missing.
So this is the repo coordinator on, right?
Yes, exactly. I'm really bad at naming, so I'm sorry.
Oh no, it's fine. The original version, sorry, the original name of Citadel was literally KMS.
So yes, that is a good name. I should steal it.
You can. It's effectively a dead project, so you're welcome to take it. It's a better name than whatever than the original. So yeah, I mean, if we want, we can spend some time making issues if folks want to work on that together real quick, get an idea of what's left, right? So like if we think about it, so what's the current state of the repo, Christoph? I think last time you said you had just started building the hierarchy kind of on the side.
So basically, I didn't know what to do because I was confused about the situation with the two repositories. So basically what's in there currently is more or less the encryption, right? So we have two layers of KEX. But for example, I'm not sure if I'm using yet the new model that Anish did with the new version 2 alpha 1 on the gRPC side. But there is some kind of gRPC listening to a Unix socket, but I don't know if it's using the right model, and it's kind of, yeah, half-baked state.
Okay, so maybe maybe a good next step might be Anish, for you to try to push some of the changes that you've done into this repo, so that way we start coalescing onto the one worldview.
Yeah, one question was in terms of the structure for this repo. So I think there are two things, right? Like one is obviously the key generation part of it, and then the one in my POC was using the crypto library, which is very similar to what the API server does. And then the second piece is the encryption part of it. So, which was very similar to what Citadel has. So that's what I took, right? The AES CBC. I think for the key generation, maybe we support different options, but for the encryption, do we also want to do the same, like CBC, GCM, and all of those in this repo? Or should we just provide one and that should be sufficient?
So let me try to make sure I understood the question. So I think I lost my thread on the first part. So I understand. I think the second part of the question is, in terms of encryption support within this KMS plugin, what is the scheme of encrypting the plain text sent to you by the API server, right? I think that's the question.
Not the DEC ciphertext. So I'm talking about the local KEK ciphertext. So we also have to encrypt the local KEK.
Right. Okay. Yeah. So I think we would. So for the DEC from the API server, we said that we would use AES GCM and would somehow encode that into our response to the API server, so it was recorded, I guess. but not necessarily make any of it configurable. I guess the same would be true for the key.
So we want to enforce that, right? Like we can basically say like use AES GCM or for the local key.
I think so. I think that's fine. I think the general feeling I have on any encryption we do, regardless of what we're encrypting, is I think we can just use AES GCM, but do so explicitly somehow. Record that context somewhere, so that way when you observe the data later, you are not like you understand that it was you that did it and you did it in this way. So that way, if we do want to add flexibility, it's not like this implicit like, oh, I don't know what this is, so I'll assume it's AES GCM instead of being like, no, I know it's GCM because I wrote it down. Does that seem fair?
Yeah, it does. But for the data encryption key that's encrypted at the API server, even for that, we want to encode that we use AES GCM. So there are two AES GCMs here, right? Like one is for the local KEK and then the other one's for the DEC.
Right.
So do we want to, I think for the local KEK, the KMS plugins will maybe include that as part of the metadata, like whatever they, the custom metadata they pass. But for the API server, we will just inject that before we transform to storage, that information.
So currently there is a local KEK, and it is AES GCM with 128 bits of keys, and it has rotation. It has kind of a max encryption counter. The only thing that's not solved is how to store it, right? So because this was where I was not sure, and then I've seen that Anish added this key to the proto. So this is something that is still missing. So the Think library gives you like rotation and a lot of additional benefits, and it has also a proto buff. So when you want to store the encrypted KEK, you can immediately put it into bytes and encrypted bytes and set it along in the proto buff. But the question is, are we fine that Think handles nearly everything and we just completely trust the library, or do we want to see if we can, don't know, encode additional information on top of it? Because then we start to tinker with Think in ways where it might lose at some point its benefits.
So let me just make sure. I wanted to write down a little bit. So we're saying API server will generate a deck and encrypt the raw data with it using AES GCM. I realize it doesn't do that today, but that's what we're saying it's going to do for raw purposes. And then we're saying KMS plugin will receive the deck from above and that server and encrypt it using a local KEK, also using AES GCM. And then KMS plugin will include and its response to the server. I think this is the one that you were asking initially about the questions where we have 3 encryptions. It's just that we own 2 of them. The API server owns the other one. And we're saying we're going to, I'm trying to remember. So we said that we would ask the upstream KMS to do this, right? So like key vault or whatever, right?
Mm-hmm.
So I don't think we control this, right? We don't actually control how this happens.
So the upstream key vault is, I think, fine, which is very similar to what we do today, right? Like today, just encrypting the deck using the KMS plugin, like as a key vault, we have no control over how it encrypts it. So the encryption of local KEK using the API server, we won't have control. So the encryption of DEC using the local KEK will be with AES GCM. So that is what we are introducing, another level of hierarchy. And I think we'll stick with GCM for that, similar to what we're doing in API server. But the Key Vault one, we never had control. So I think that doesn't really change anyways.
Yeah, so right. So okay. So
the second one is the new one.
Okay, yeah, so you were asking about this one, not
exactly. Yeah, not the third one. Third one, I think we just never had control.
Yeah, so it will include an encrypted local kindness response to the API server, the format of which is dependent on the upstream. I don't know if we want to use the word upstream KMS, but that's what I got right now. So I think now to Christoph, your question is, I think, is related to item number 2, which is the management of this local KEK. Roughly, I think is what it comes down to. Is if we use Tink, I think, are we? I guess how strong is that library's opinions on how all of this is done? Is there any configuration, or is it like completely a black box and you just use it?
Well, I could theoretically share my screen and guide through it. Otherwise, I could try to do it in speech, whatever you prefer.
No, I everyone co-host so that everyone could share their screen.
Okay, then let me try to open the project first and then share it. Open recent. Share screen. Got window service. Okay, let's see. I'm not usually a Visual Studio Code user, so let me. Okay, KMS. So what? Let me go. Do we have a vendor package? No, but can I go to Tink like that? Can I double click here? Okay, then let me do it by hand. Open folder. Okay, so they have they have very strong opinions what they let the users do. So they don't want the users to shoot in the hand in the foot. So basically, they have several abstraction layers. For example, we have the key handle, which basically is just a high-level measure which enables you to. So they have also so a handle has basically a key set. A key set is a set of keys. And one of them is mentioned to be a primary key, which is the one in use. So when they encrypt, they also add a prefix. So they can efficiently pick from the key set the right key to use to decrypt, but just the primary one is used for encryption.
Yes. Sorry. Is this, whose code is this? Which code base are we
in? This is Google Tink. Just to give you an overview of Google Tink.
Oh, okay. So this is not code we can change. This is only code we can consume.
Yes, exactly. This is why I said depending on how much flexibility we want, it might be a deal breaker for us.
Right.
And the new handle basically says it gives you the methodology to read the KEK. So for us it would be the local KEK, right? And it gives us measures to read it, to write it, and that's more or less that. a layer below, they have a kind of the notion of a manager, which manages the key rotation. So it enables you to rotate. And as you see, the whole encryption is basically abstracted by some key templates. So when you want to, for example, use WG-KMS key manager, then you have some kind of templates that do everything for you. And then you basically choose, hey, I want this template, you use it, and then it's used. And they have some protobuf, let me find it. Boom, boom, boom.
Are these templates interfaces, or are they raw structs that the package expects you to use one of?
That's a good question. Where was it? Yeah, I had the key templates. So let's see WG-KMS key template. Yeah, so basically they choose the key size, a prefix to identify the key, I would say. And underneath that, when we go down, we see that here we have the proto that marshals in the protobuf. Yeah, so it's basically just predefining a couple of things. But when you go down to the subtle thing where the actually encryption happens, you see that they use the native libraries.
Mm-hmm.
And they do nothing special. Maybe a little bit special with the prefixes that they add to it. The same thing that basically it's on Kubernetes where you try to add a prefix to identify the key and the reasoning about it. And they do everything for you.
Mm-hmm.
And the protobufs, I would need to see how they look like. But basically, this is also more or less opaque to the user, so they don't expect the user to do it. For example, they have what I use, for example, was I think binary IO was basically I used a buffer to write the encrypted. So when you write, you give the from the upstream KMS, you would you also need to give some kind of key set. So we would need to bridge this somehow. But this should be trivial because they have the KMS implementation already, at least for Google, right? And I think for AWS and for Microsoft, they were missing. So this is somewhere in the code already, how to do this, how to bridge this. And then basically they write it, right? So write is here, go to definition. Yeah, and then use then the proto, and they have some predefined proto messages. Where they marshal this. So for us, it would be more or less opaque binary, and would completely delegate the cryptographic logic more or less to the Think library. And this is the question: if this is sufficient, or we say no, we want to have more fine-grained control, then we would need to look at how we can break it up. And when we are working more against the framework or with the framework?
Yeah, I guess in my head, what I had imagined is what we were. This is, none of these opinions are strongly held. This is just like how I'd imagined it. Is what we could do is in this V2 Alpha 1 API, right? That we would basically, still have encryption and decryption, but basically have dedicated sections in both of them for effectively arbitrary metadata, of which one of them is the key, if the KMS plugin wants to do that, right? I think it would be reasonable to say if you have a KMS plugin that is purely just an abstraction for a piece of local hardware on the box or whatever, like a YubiKey or whatever, it doesn't need any of this fancy key hierarchy or any of that abstraction, right? Or even any concept of rotation, because you can't, it's in hardware. It's literally sitting right there. So in that sense, that KMS plugin implementation would simply just return the encrypted ciphertext back to the API server, and its metadata would just be empty. It's like, I don't need any metadata. I encapsulate one configuration. There is no change. I am static, right? But for us, what we're saying is in that metadata, we would include like an encrypted key and maybe like what the upstream key vault key name was and things like that, right? We would just include that metadata information in there. And then the API server is expected to turn around and send that back to us when it asks us to do decryption, right? Blindly, it's opaque to it. And in that sense, I was kind of thinking that would mostly be how we held our encoding format, right? Because it would, like for the most part, the key would just end up then being like a string, right? Like it might be a slice of bytes, whatever, but effectively the like I don't think we need anything like prefixing and stuff then, right? Because we like the reason for using prefixing is when you're like, I have like effectively a flat set of bytes and I need prefixes to like do that, right? And I'm saying I don't want to keep doing that. I want to have a proper structured thing that has fields for me to use, so I use the fields.
Yeah, so they use the prefix in a case that you have more than one key, which in this case would happen, in Oyo's case, would happen, for example, when you encrypted more than, let's say, 1,000 or 2,000 times, depending on how high we set the number. And it might never come to the point, right, when we would enable to do 1 million encryptions, it might be always just one key. So then it would not be necessary. But if you would have more than one key, the blob would be bigger, right? It would contain more information. It would have 2 of those in protobuf encrypted. So this is really the question, how fancy we want to make it. We can also do it plainly with IHGSM, because maybe the rotation is not worth to have this framework in place, because it should be quite simple.
Yeah, I guess in my, I don't know if I guess I don't have an opinion necessarily on how the rotation is done as much as that we do it. But in my head, I imagined that if we give the KMS plugin a space to store its state that is persisted by the API server, I think most of the complexity necessary for like prefix and all that kind of dissolves away, because it doesn't have to remember everything in like one slice of bytes. It can say, cool, like I know the name of, like I know that I have the concept of a name of an upstream key, I'm gonna put that here. And I know that I asked it to encrypt my local KEK using some proprietary protocol. And this is the slice of bytes it gave me. I'm just gonna stick them right here. Right? And then if you have all that, then like, yes, we want rotation after, you know, some n number of writes from the local KEK, but we don't have to actually remember any old KEKs or any old local KEKs or any future local KEKs, because it's a point in time storage, right? And whenever we get it back, if we don't happen to know at that instant how to do it, we just ask the upstream, like, hey, you said that if I told you that I was using, you know, key vault 77 key, if I gave you this random set of bytes, you would magically turn it back into the decrypted state. Can you do that for me? Because that's what I need you to do, so I can do what I'm supposed to do.
But we will have several KEKs, like for example, we have several plugins, right? So we will have several of those local KEKs encrypted somewhere on the disk. And how would we associate, for example, the ID or something like? How do we know that this local KEK is used to decrypt this stack?
Right. So when an encryption response comes in from the API server, right, it will give you like, hey, here's the plain text I need you to encrypt. We will encrypt it using the local KEK, but in the response, as part of the metadata, we will include the encrypted local KEK and other metadata we need to later redo this, right? So we did that, and let's say we crash immediately after that and restart. So we've lost all of our local memory. The API server immediately turns around and is like, hey, I need you to decrypt this data that you had helped me previously encrypt. So it would just pass us back that metadata and be like, cool, we have no idea what that encrypted KEK is or really how to do anything. So we need to ask the upstream key vault to help us basically re-cache the correct key, right? which is I think what Anish did, just like reusing a lot of the existing Kubernetes code base, or Citadel, some mixture of Citadel plus Kubernetes glued together in some way.
Yeah.
Yeah, sure. Then we might not need Tink, right? Because it's then nearly stateless, I would say, right? So we have the keys, we send them, and the local encrypted keg is more or less bound to the decade encrypted, and yeah, and then we could just compare the bytes, I would guess, right? So when the API server has a decryption request, it sends us the encrypted local keg. We see the encrypted local keg, and we would then look up if we would not like to always decrypt it, right? So we would check if the encrypted local keg is somewhere within our cache.
Mm-hmm. Yeah. Totally.
But then the question is, that when you encrypt one, I don't know exactly how the upstream KMS works, but when I would say to the upstream KMS, look, I have key A, and could you please encrypt key A? Then encrypt key A for me. And when I would do the same, I would ask again, could you again encrypt key A? Both ciphertexts should look differently, right? Because when you encrypt the same plain text twice, it should be different because you add a different initialization vector. So the encrypted cipher, even when you have the same plain text, looks differently. So you can not make any statistical attacks on it or stuff like that. So it would be really hard for us to say that even though it's the exact same local keg, it would always look different for us. This is why it might be beneficial to have some kind of an ID for the key.
So I don't think I'm following, because every local keg would be generated one time in memory by one particular instance of the KMS plugin, right? And so during its entire lifetime, as it's used, it will only have one representation. It'll have one set of random bytes, which is its plain text, and one set of random bytes, which are its ciphertext, right? And that same ciphertext will be shuffled around, right? Like, at no point will a different instance of the KMS plugin try to reuse that key as a write key. So there will be never more than one call to Azure Key Vault or whatever to encrypt that plain text. There might be many calls over the lifetime of your Kubernetes cluster where you ask it to be decrypted, but obviously, no matter what, Key Vault has to return to you the original bytes you asked, otherwise nothing is going to work out well, right? So am I making sense?
Yeah, I mean, I can add to what Mo mentioned, right? So basically, today in the Cube API server, we do exactly that, right? Like, we have this LRU cache, and then what we cache there is the encrypted deck, and then obviously the plain text deck is the value. So this encrypted deck comes from the KMS plugin. And then the way I did that in the POC was there is an LRU cache where we have the encrypted local keg, and then the keg in plain text as the value. So whenever encrypt call comes in, we just check in the cache that if we already have the keg in the cache. If it is available in the cache, we use that and then just encrypt it and send it back. So this is just for us to avoid making an external API called the upstream KMS key vault. But if it's not in the cache, then we generate a new keg, right? Like, I mean, if the keg has already been used for a certain number of times, so that's one scenario. But in the decrypt scenario, the API server will give us the encrypted deck ciphertext, and then it will also give us this additional metadata that we shared, which is stored in etcd. So the KMS plugin will look at this metadata. It will extract that encrypted keg from it, and then the cache lookup. Even if you think of the cache as just a map, in the cache lookup, it's looking for this particular key, which is the encrypted keg. If it is not in the cache, it says, okay, it's not in the cache. So it in the metadata, there is the encrypted key and the key ID, which was used from Key Vault to encrypt it. So it will go to Key Vault and say, hey, look, this is this encrypted data that I have, and I had encrypted using this particular key ID. Can you decrypt it for me and give it back to me? And once it gets it back, it will add to the cache. So what it adds to the cache is that encrypted key and then the plain text key. so that in the future, when it gets calls to decrypt, it can just see it in the cache and not make an API call externally. And
Okay.
like Mo said, the key is only generated once, right? Like it's generated at the start, and then if it's used for 1,000 operations, your cache value is the same. Like the key encrypted keck, and then the key is just going to stay the same, so it does not change in any way. So even for if you get calls for 1,000 encryptions, you're always just getting it from the cache, encrypting it, and sending it back.
Yeah, I think I would need to look it up. Basically, the point that I wanted to make is that when we would encrypt the local cache twice, it might look so the ciphertext should ideally look different. But when we only encrypt it once, it's not a problem.
Yeah, so I agree with you that if we encrypt it more than once in any path, then yeah, it would. That would not work out well for us because it's not going to produce the results we want. But as far as I understand, we don't have any need to encrypt it more than once. We would just.
Okay, sure.
So I guess what I would ask is in terms of like rotations, like so I don't think we need Tink for encoding stuff. I think we have enough control on the proto side on Kubernetes and everything to just give us a nice API that's Kubernetes style. How does Tink do like the actual rotation? Is it counter based, or what does it do?
No, actually, I don't think that they have a counter. When you create a new handle for a key set, so we give a key template. So we want to say it's ASGCM with 128 bits. Basically, it does on the very first thing, it creates a manager, makes the rotation, and then uses the rotated key set and gives it to the handle. So it's basically from the start using a rotation. I didn't see any logic that has some kind of counter that checks that you don't use it, I don't know, 1 billion times or something like that. It basically adds, it rotates, it adds a new key, returns the key ID, sets it as the primary key, and when we go here to go definition, add. Yeah, so here it manages the prefixes where it assigns, I think some, so there's an old version of the prefix and a new version of the prefix.
So is rotation auto, or is that something that just the client has to invoke manually? Like it doesn't do anything on its own, right? So
it does it not do it on its own. So what I did, I added a counter, an atomic counter that on every encryption it counts up. And once it reaches a certain threshold, we initiate to Tink a rotation. But again, it's not super complex, right? So if we say, okay, that we need to work too hard against Tink, we could just do rotation on ourselves. I thought it's just quite nice to do it on behalf of us. Yes, so we have new key set, key data. It depends, right? So the new key to the existing keys.
Okay, so if I understood correctly, rotation is manual, and the app basically decides when it's appropriate to do rotation?
Yes, this is how it works. I didn't see any automagical measures in the encryption to handle that.
That is a little bit surprising to me, because I feel like, I don't know, I feel like that's like the hardest part, is to actually make, like in the, like, yes, the code itself for rotation is complex, but having the caller need to know to do it also seems kind of bad.
Yeah, so this is actually what I did in the current implementation, that I have the counter and manage on myself. Yeah, but the question is if it's really such a problem, because we said that we don't mind so much about the counter, right? So when the KMS plugin boots up, it creates a new local cache, and
yeah, we don't need to store the counter strongly. We just literally just have to have it in our cache RAM for the current key. Okay. I mean, so I do see that within this library is the kind of cryptic and annoying to write encryption code. I know this because I copy pasted it out of the API server into Citadel. And that code's not exactly fun in any way, though I suspect because of the prefixing stuff, we couldn't actually, we can't move the API server to use this library, right? Because it would actually try to change what's on disk, right? Which is unfortunate.
We can also switch to the native libraries.
Yeah, no, I was trying to think if we could somehow try to collapse Kubernetes onto this library, right? Instead of having our own handwritten crypto.
Well, it's not completely handwritten. We are just using the tools that are given by the language, right?
Oh yeah, I know, but the language tools are like pointy and sharp, and like if you do it wrong, it pokes you in painful ways. That's all. I was trying to think of if there was a way we could derive value from the higher order abstraction of a more managed encryption interface and less of a very carefully written bytes prefix and length magical stuff. Okay.
I think there's no middle ground between completely newbie friendly and completely left on your own. So I think there's no middle ground.
Yeah. I think my current gut feeling is saying that we probably just need to use what's already in KK, unless folks think there's some specific value out of this library that, I mean,
I'm fine using the native stuff. I'm fine. I just hoped it would give us some benefit, but again, it quite frequently happens, and we have a strong opinionated framework that it's too hard to use it because you need to adjust. I know, like Java Spring, right? So I don't know, when you look into it, it's quite opinionated, and you need to live with it and adjust to it, and not the other way around.
Yeah, listen, it's a little unfortunate. I mean, I understand why you would want to be strongly opinionated on something like this.
Yeah, but I think it's open source, right? So we can take the good ideas.
Yeah, totally. Okay. Okay. So I think what we're saying is we want to basically borrow a bunch of code from Kubernetes, primarily the AES GCM one, right? Like we don't actually want any of the other stuff for our internal encryption logic, right? Because we're not worried about that. So I guess what I would want to see is if we have basically a dedicated field for metadata in the proto that we're going to send back and forth between the API server and the KMS plugin, I'd want to see like what does that look like when you're using hardware, local hardware, versus like Key Vault versus like I don't know, GKE, some whatever, secret manager from GKE, I guess, maybe, whatever. Like if we had those, I'd be curious to see what those end up looking like. To see, I don't know, like should we have just an open-ended bag of metadata, or should we have some middle ground where some fields are more strongly typed and made clear, and others are more open-ended?
Like annotations in audit logging?
Yeah, like would we want to explicitly have like a key field, like a key ID field or something, and like effectively a bag of values, which is effectively annotations? Or do we just want everything in the bag of values and like it's just completely up to the KMS plugin and its implementation?
Yeah, I think only thing is if we have it as like a typed one, then basically if the KMS plugin has to extend it, it's not possible, right? Like you have to come make changes in Kubernetes, and then make changes in KMS plugin.
Yeah. That's fair. That's fair. Yeah. So yeah, I guess for me, I think the next thing that might be the most clear to me would be just like if we can hash out what the V2 Alpha 1 proto would look like, so that way we can just make sure that it kind of makes sense. Like I realize we still haven't figured out the full rotation story from the API server side, but I think that's tractable. It's just a separate problem that we need to look at. Yeah.
Yeah, but in terms of like, I think immediate next steps. So, what do you think? So, whatever I have in the KMS plugin now, like whatever I did for the POC, I can extract that to a library. So basically, it'll be a new key generator which borrows the generate key and all this code from the Kubernetes repo, and then the AES CBC part, I had taken it from Citadel, but I can see if we can take it from Kubernetes, so that like we can just use that. And then I think the next thing is, do we want, I mean, I can start a doc on everything I did in the POC, which we can eventually convert to a KEP. Do you think that would be the right direction to go? And then with rotation being the last thing that we want to finalize.
Yeah, I think the parts that are not fully clear in my head regarding a KEP is what is the on-disk storage format? What does that look like? Mm-hmm. So the proto for basically is for storage in etcd. Mm-hmm. What is the V2 Alpha 1 proto format? So the communication channel between the plugin and the API server. That part needs to be really solid and specified, so that way it's kind of clear. Within that API, right? What are the other extensions we need for the rotation bits, basically? Mm-hmm. I don't know if we're at the KEP stage or if it would just be easier to like as a for example, we could have a shared fork of the Kubernetes repo, just a public fork, not a private one or anything like that, where we just add the V2 Alpha 1 API together, just so that way it's just in a shared spot. We can kind of look at it and play with it and make comments on it or whatever. And then in another shared repo, we would have the KMS plugin implementation of that, right? So that way, like we don't have to have it all working or anything like that. I'm just more, I think I need a little bit more crispness in my head to like be able to say we could write a KEP that would be complete.
Yeah, I was thinking we just start the doc so that similar to the fork, right? I was thinking we can all just keep commenting on the doc, and then like once it's concrete, then that would become the KEP at the end.
Yeah, I guess if we wanted to have a doc where you just like copy pasted the KEP template in it as a starting point and just started adding stuff to it, so that way at the end of it, yes, you can literally just make the KEP out of that doc. That way I think that's fine. I don't think that's a bad approach, because I think we have a general high-level picture of sort of where we want to go. Just a few I think few details are left in regards to just managing how basically the rotation around like the true KMS, right? Like when Azure Key Vault does a rotation, how do you funnel that through the stack so that way Guy server knows that it needs to do something. Because the local KEK being rotated, I don't think actually meaningfully matters. I don't think anyone actually is concerned because the upstream key hasn't changed. So it doesn't doesn't change anything.
Yeah, the local cake over rotation doesn't add any kind of overhead. Like it just works without any big changes. Like it's all in the cache. And
and it's also like depending on like which KMS plugin an API server talks to, right? It's going to have a different local kek write key, right? So it doesn't conceptually mean anything. You're not achieving a particular version because every API server has its own KMS plugin, which has its own in-memory local kek, right? So that's not the rotation you're trying to achieve. That hierarchy is simply there for performance reasons. It's not there for a security boundary. The upstream KMS is the security boundary, and its rotation is the one that we want to be able to coordinate to the stack. I think in the library, I think another thing that would be nice to see is some kind of like interface, like Go interface definition of like how we want to express some of this stuff, because presumably we would have an interface that is able to handle the local hardware key based encryption, as well as this like delegating key hierarchy encryption. So you would have, it'd be like a double abstraction, right? You would have this interface implementation that's like, yeah, I manage this local key, but then it would have probably as an input the true upstream KMS, right? And that would also be some kind of interface. Maybe that doesn't need to be in the KEK, but I think we need it in the code base somewhere, right, to actually point at and talk about. That part's a little bit harder, I guess, because it's like, well, what each upstream has its own strengths and weaknesses. So how do we make sure that those are still viable and useful in the plugin?
I think that's the hard part. Let me try pulling it out of my code and whatever I have so far into a library, and then we can probably like all collaborate on that one and keep add to that, like basically the interface definitions and everything.
Okay, so do you want to do that in Christoph's repo? That way we're all just in one place.
Sure.
But this is the question, right? Because my repository had some assumption like around think, and now it deviates very strongly from what we came up with. So the question is if it would not make sense to maybe work from Anish point proof of concept, because it's closer to, I mean, basically, Anish would need to remove nearly everything and put his proof of concept on top of that, which would be kind of silly, right? So maybe
so okay, I think though, because Anish's proof of concept is on the KMS implementation on the Key Vault one, I think what it might make most sense is to just start on a blank repo, right? Like an empty one, and say, all right, like we're going to build the KMS plugin, and it's like right here, it starts from nothing, because we want to separate it from Azure Key Vault, right? Because that's just one upstream implementation, right? Like one that we want to support along with the other two major cloud providers, because everyone wants their fanciness. And yeah, I think I agree that if the whole library is around Tink, then it probably doesn't help out too much to coordinate on it, which is fine. Yeah, so if we, do folks want me to go make a repo real fast and be like, there you go, you have commit access to this repo?
Okay, let me just create one so I can pull the code out of my POC and put it in there eventually.
Yeah, okay, cool. Yeah, so let's do that. Let's have like a blank starting slate.
Yeah, I'm going to name it. Sorry, go ahead.
I was going to say, I think actually, now that I'm thinking about it, we can pretend for the first, bit, let's just assume the API server has been updated and can handle the new API. Let's just assume that for a second. You can put the full v2 alpha 1 proto definition in this repo, right? Because it has to have the server implementation in this repo. The client is inside the API server. We're just going to pretend the client is already done. Right. So then we can we can hash out the proto in this one repo, right? We can go, yeah, this works and this doesn't work.
Yeah, that sounds good because that's what I had to do for the POC too. I just basically added the files here in the key vault stuff too. So I can add that in this repo and we can basically PR or add comments to it.
Okay. Cool.
So Anish makes a repository. We get all an invite. Then he pulls over the proof of concept, and then basically we come up with issues, and whoever can picks them up, and like so.
Yeah, I think that's fine. If not an issue technically for the repo, but if we wanted to start a doc as well, that's just like the kept template. Just if we wanted to have if a Google Doc was more conducive to some kind of conversation versus a Git repo, that's fine. Yeah, I think the hardest part from the library implementation bit is giving the right extension points. So that way, if you wanted to implement your own, you could get the benefit of most of the code and plug in the bits that you want to change. Right? And to be fair, we would be able to exercise that extension point pretty well by literally saying, well, you have to support this, and this other thing that have well-known implementations for it. Yeah, I think that's a good starting place.
Yeah, I think let me extract it and then we can build on top of it. And I'll also add the proto here so that we can make changes to that as well and finalize. Yeah, I just named my repo KMS. Following along.
Oh
no, don't do it. Don't do it.
Or Citadel with an S or something like that.
That would be funny. That would be a funny way to do it. Oh, man. All right, cool. All right, we have like 2 minutes. Anyone have anything else? Damien, you've been awfully quiet. Did you have anything, sir?
No, I was trying to catch up mostly, but I saw they could tell you are trying to iterate over the couple of action items that we found over the last couple of months. So it's great that it's finally taking some place. And yeah, I don't have much comment because I feel that the discussion that happened today are kind of like things that we already figured out in the past. It's more like how do we iterate over them? So we're just trying to figure out like where we stand today, and I was trying to catch up.
Okay, I just sent out the invite for that repo. So.
Thank you, sir. All right, cool. I think we can drop off and continue offline.
Okay, cool. So maybe once, so how do we do with the issues? Who creates them? Do we create them collaboratively?
I think I would err towards the side of if you think something needs an issue, just go ahead and make one, and then if we think it's invalid, then we can just say, here's the reason I think it's invalid. Or more likely what's going to happen is like, oh, by the way, I think there's 5 other issues that are similar to this. Let's add more issues. But yeah, I think it's fine. I wouldn't be too stressed about making too many issues. I think that's better than not enough, in my opinion.
No, I'm just more concerned about splitting up the task so we don't do something in parallel.
Yeah.
Okay, cool. So we'll just wait for Anish to push code. They look at the code, and then if there are no issues, I might create some of them.
We'll see you all next week.
Bye.